Hello everybody, welcome to Code Vipassana Season 9 Session 2. This code lab will be all about building a contextual yoga poses recommender app with Firestore, Vector Search, Langchain and Gemini. This code lab will be done entirely in Python. You must remember if you've completed the last lab that was done in Java and was around a similar topic. We have chosen to do this in a different programming language to serve diverse programming language interests. Let's get started. As usual, if you're new to this, don't worry, the code labs are made in a way that you will not have any confusion. These will teach you how to implement these technologies and also how to learn about them. To start off, just a little bit of introduction about what we're going to do. We're going to be using a Hugging Face dataset with yoga poses inside of them in JSON format. Then we will enhance the dataset with additional field descriptions using Gemini to generate them. Then we'll use Langchain to create the documents and store them in Firestore to create the collection and embeddings. Then we can create a composite index in Firestore to allow for vector search. Lastly, we'll utilize the vector search in a Flask application that brings together everything as shown here in this screenshot. Okay, I've already told you what you'll learn, so now for what you'll need. You will need a Chrome web browser, a Gmail account. Please note Gmail, not Yahoo, not iCloud, not anything else, a Gmail account and a Google Cloud project with billing enabled. Okay, if you have that, we are good to go. Let's start. Okay, before we begin, again, we need to go to the Google Cloud console and select or create a Google Cloud project. Let me show you how that's done. We can go to console.cloud.google.com. Click here in the top left. We can select any of our existing projects while making sure they are connected to a billing account, or create a new project. I am choosing this project since I've already created one. This is connected to a billing account. You can choose to either use the same project or create a new one. Now, since we've already ensured we've selected a project and we've also made sure that we've enabled billing, let's use our Cloud Shell editor and terminal to start with the commands that we need to use. Throughout this code lab, you will notice there are multiple commands that we require you to perform in a terminal or in an editor. So what we'll do is we will go and open the editor in a different tab. So we can have our Google Cloud Console homepage on a separate tab where we can access other pages like billing or Firestore, etc., etc. And we can have our editor and terminal open in one another tab. Let me show you how to do that. You can go to the top right of the page. This is the Gemini icon. Beside the Gemini icon, we can click on Activate Cloud Shell. Let it open. It will ask you to authorize the machine. Click on authorize the machine. After you've authorized it, you can click on open in new tab. What this will do is it will open your editor and terminal in a completely different tab. With a click of a button, you can close this terminal and you can open the editor. Notice how this editor seems very familiar to you because it is built on top of an open source project like VS Code. So to help you with familiarity, this will help a lot. And on this page itself, you can see you will have your own terminal also. If you do not see this terminal open, what you can do is you can go to the hamburger menu, you can click on terminal and you can click on new terminal. And there you see there is a terminal. Let's start with the project. The first command we need to implement is gcloud auth list. What this will do is this will show us about if our Google account is connected to the terminal or not. You can see it says active star account mohitbhimraj@gmail.com. That means my Google account is currently connected to this terminal and we're good to go. For the next command, we can click on gcloud config list project to see if our terminal is currently listed as a project. you can see it says project unset. That means we will need to set a project which we identified in our home page. Do remember that your project ID is very important. So you remember what your project ID is. If you don't remember what your project ID is, you can always come back here, click on the projects tab, and look up your project ID just here under the ID column. My project ID is test-code-vipassana, and I will be using that throughout this demo. Let's proceed. If your project is not set, you can use the following command to set it. Let's use that command to set the project. I will paste the command and I will replace your project ID with my actual project ID. You can see the project ID is now shown in the terminal itself. That means your project ID was successfully accepted and now your terminal is connected to that project. If you still want to check, you can run the previous command that we had run to check, and it will show you project equals your project ID. We're good to go. Now, to build this application and to do a lot of the things that are required to be done, we will need to be enabling certain APIs. You can enable them by copying this command to the Google Cloud terminal and running it. But what I prefer and what I think is the safest option is you can use this hyperlink to, it will enable all the APIs in one shot, so you don't miss out on anything. Let's click on next. You can see we have the cloud Firestore, compute engine, service networking, cloud run, cloud functions, Vertex AI, a lot of APIs to enable. We click on enable and we see that the Google Cloud has started working. Now that the button is grayed out, we can see that all our APIs have been enabled under this project. So we can close this tab and go back to our terminal. The next step is to clone the repository from which we'll be getting our code. So we are already in the Cloud Shell. So all we need to do is copy this command, go back to the terminal, paste it in the terminal, press enter, and our data will be cloned. You can see you really can't see what the data is, what the code is. I will show you how to use the editor exactly for this purpose. What you can do is you can check what your current directory is. I would prefer press CD and press the tilde key. You will be led back to your home directory. Press LS to see all your directories under this current directory. You can see that the repository we just cloned is called Yoga Poses Recommender Python. So what I can do is I can press CD Yoga Poses Recommender Python, and there it is. I am under this repository and I can work under it. If you want to open the files here, you can select the folder here, click on OK, and it will initialize the terminal and the editor inside of this cloned folder. I can click on terminal, new terminal, and you can see I am inside of this project now. A very important thing to note is that our project ID has become unset now, so we will need to set it again. How we can do that is copy that command and again replace your project ID with our actual project ID. And there it is. Our project ID has been set and we're ready to work now. Okay, now that we have the folder open in our editor and also the terminal is configured, we can proceed with the next steps. The next thing that we require to do is configure a config.yaml file. We already have a template in our repository folder. So what we can do is we can copy and paste this file to create a new config.yaml file. You can see the copy has been created. What we need to do here is we need to replace your project ID with our actual project ID. In my case, it is test-code-vipassana, and we can leave everything else on default. We can close the previous file and rename the new file by calling it config.yaml. You can see that it has taken config.yaml, And now we can move to the next step. It asks us to update the project ID and location. We'd like to leave the location on default to US Central 1 since that is the location of our databases, etc. Again, project ID is something that you need to update for yourself, but other than that, you can just update it, rename the file, and you're good to go. Next, what we need to do is we need to make sure that we have the dependencies we need properly configured. For this, let's check out the pyproject.toml file. Let's find the pyproject.toml file. Here it is. You can see the dependencies are as shown in the file here. These are also already set in the requirements.txt file. So what we'll need to do is we'll need to go to the virtual environment and install all these requirements. For that, we'll need to create a virtual environment. It is very simple to do that in Google Cloud Console, especially in this editor. All we can do is follow the steps that are given here. We need to go to the command palette by pressing Ctrl+Shift+P, type Python create environment, and then select the steps to create an interpreter and the requirements.txt file. Let's do that. Let's close this file, press Command-Shift+P. We can type Python create environment. You can see it's there. You can see it creates an environment with when. We can choose any interpreter we like, anything. I'm using the first one. Dependencies to install. We already have a requirements.txt file. Click on OK. You can see that it's creating the virtual environment with all of the dependencies. It's created a .when folder where it will store all our dependencies. Let it give its time. You can see that we've successfully created our virtual environment. To activate our virtual environment, all we need to do is copy this command from here, paste it in the terminal, make sure you're inside your folder that you've cloned from GitHub, press enter, and you can see you are inside of your virtual environment, and it also says your Google account name. Good, we're good to go. Okay, now what we need to do is we need to set up Firestore. Google Cloud Firestore is a fully managed serverless document database that we can use as a backend for our application data. What we can do is we can create a structured collection of documents. I will show you how that's done. Let's go to the Firestore page. I will copy the link, paste it in here, press enter. You can see I already have one database which is called default, but for the sake of this code lab, I'll delete this database and start over again. Do note, if you have completed the previous code lab, this will be the database that you've used. So please make sure that you submit the results of the previous code lab with the working environment before you delete this database and start with this code lab. I'm clicking on delete because I've already done that. You need to type the database ID below, which is default. So I will do that. Press delete. The database is deleted. Now we can start with our steps. To create the database, we need to click on create database. We have to select the native mode, click on continue. Multi-region is fine. Please make sure you do not select the production rules. You have to select the test rules so your data is accessible to you, and you can click on create database. It will hardly take 5 to 10 seconds to create your database, and once it's done, it will greet you with a screen something like this. As you can see, I have gotten an error right now while creating the database. This is because we had just deleted the default database that we had, so Google Cloud takes a little bit of time to make this change. Make sure you wait for a minute or two, refresh Firestore, try creating the database again, and you will be successful. Like you can see on my screen, after I've refreshed and tried again, Google Cloud has been able to create this database. This is just a minor syncing issue. As you can see, it's no problem. We are ready with the database, and now we can start getting in the data by following the steps from the code lab. Let's go back to the code lab. We have detailed steps on how to proceed. As we can see, we have to create a collection named poses inside our Firestore database. That's what we're going to do in this next step, where we prepare the dataset that we want to use in our Google Cloud project for this recommendation system. What we can do is we can visit the Hugging Face page hyperlinked here to take a look at the dataset we're going to use. It contains different things from the name of the post to the type of the post to a URL of the post and etc. etc. For our convenience, what has been done is that these files have already been added to the GitHub repo that we have cloned. So we already have this data inside of our project. But if you wanted to use it on your own, you could go to the files and versions section of this data, go there, click on download, and you would have been able to download the data in JSON format. Coming back to our Google Cloud project, as I already told you, if we go back to our Google Cloud project, we can see that we have all the data in a file called yoga poses all data.json, and this contains all the 150 plus records of all the yoga poses. For simplicity, we have another file called yoga_poses.json, which contains only 3 records that we can start off with to make sure that we don't end up using a lot of processing time, and this gets done in the scope of this session's code lab. You might have noticed one thing, that all of our data has the name, the URL, the post type, expertise level, but what it does not have is a description of the post. That is exactly what we're going to generate now with the use of Gemini. We already have a pre-built function in this GitHub repo by the name of the file generate_descriptions.py. We can use that to generate the descriptions for the first 3 records and then see how it works. We can use this data to now import the documents into our Firestore database, and we can follow this later with importing the other documents into the database. Let's see how that's done. We have generated a new file called yoga poses with description.json, and we need to populate the Firestore database with this JSON file. How we can do that is we will convert the JSON object file into a Langchain document. Each document will have 2 attributes, page content and metadata. Once this metadata is converted, we can use the import.data file that we already have in our GitHub repository, copy the command, go back to the Google Cloud console, paste it in the terminal, press enter, and you will see that it will start importing the data into the Firestore database. Once it has been imported, you will see that it gives a successful message, and once that's done, we can go and check it in the Firestore Studio if our data is imported or not. As you can see, it has created a new collection called test-poses, which has the 3 documents that we had just generated descriptions for, and those documents are very well imported into the database. Now what we can do is we can follow the steps in the code lab to import all the other documents we have into our database. We will be using a gcloud bucket to accomplish this task. We will be using this gsutil commands from our terminal to make sure that we import all the data from our GitHub repo to the Firestore database. What we can do is we can copy the first command, we can go back to our Google Cloud project, in the Cloud Shell, use the terminal, paste the command, replace project ID with your actual project ID. In my case, it's test-code-vipassana. I will be using that. Once that's done, you can see a Google Cloud bucket was created. We copy the next command, we replace the project ID with our project ID, same exact process. What this will help us do is it will take us the data from this GitHub repo to the cloud bucket and put it there. And after this, the third command, what it will help us do is it will actually help us import that data into our Google Cloud Fire Studio. Pretty cool, right? I know. We can move forward with this step. You can see inside the Fire Studio, we have all the data available inside our new poses collection, all 150 plus records with unique document IDs, with the descriptions, with the names, with the post type. Everything is inside our Firestore Studio. So now we have the data prepared, and the next step we need to do is perform vector similarity search in Firestore. To perform this function, what we'll need to do is we'll need to generate Firestore composite indexes. These composite indexes are a very integral part in making sure that our search queries succeed. What we can do is we can copy the following gcloud command into our terminal, press Ctrl V. We can replace your project ID with our actual project ID, press enter. You can see that it started to build the composite indexes. Once it's done, it will show you a message. Then you can go back to the codelab, copy the next command, which is listing the index that you just made, so you are sure that you have created an index. Press enter. You can see there is our index. We're good to go. Since we have the database and the embeddings ready, we'd like to test if our application works. We have a file called search-data.py to do exactly this. We will put a prompt saying recommend me some exercises for back pain relief and see if it can process the request. You can see it's recommended some poses along with a description and given us a wonderful output. You can also see that the same snippet has been given in the codelab. I can say that we've successfully built this application. The last part is testing out the web application. You can run the app locally by copy and pasting the command python main.py. What this will do is this will basically run the main Python application on a server, on your local server. I've copied, pasted the command. You can see it's running on the local server. If I click on the link, I will be led to a page where this website is hosted. You can see this opens up your newly deployed app in a new tab. You can search for anything you like. One example that we've been given here is we can search for exercises for back pain. So that's what we're going to do. I'm going to copy, provide me some exercises for back pain. I'll paste it, press search, and look at that. We have the results in front of us. The next step that we can do is we can actually deploy this on Cloud Run. We skipped this in the last code lab because it is a little bit of a lengthy process, but we will show it to you this time. Cloud Run basically means that you can deploy it online for anybody to see. You can share the public link with them and they can interact with your application. This is a very simple process. What we need to do is we need to copy this command, paste it in the terminal, replace our project ID with the actual project ID. Before this, we have to make sure that the config.yaml file is created. This was done in a previous step at this code lab. So if you do not have that file in your project directory, make sure that you have it. Before running this command, make sure that you're inside of your Google Cloud project and also that you change the project ID from the double arrows project ID to your project ID. You can provide it the authentication it needs to deploy it on Cloud Run, and once you press enter, you can see that it has started building the application. It will go through multiple iterations, multiple steps to containerize and build this application. Once it is done, you will see that it has shown you that this is the URL your app is available on, and you can click on that, go to the URL and see your newly built application deployed on the web. You can share this with anybody, you can test it out. I'll just show you how I'm testing mine out. I enter a very basic query, click on search, it is running the indexes, searching, it gave me the result, and we can also use the play audio button.
Reverse corpse pose, Advasana, is a beginner prone pose. Lie on your belly, arms at your sides, relaxing completely. Benefits include stress release and spinal decompression. Ensure your forehead rests comfortably on the mat.
We can test out another pose, test out another query. Let's say I have a severe leg pain. What pose can I do? Let's search it. It will show us the top 3 poses that it recommends us to do. Again, bound angle pose, lunge pose, hero pose, and we can also listen to the audio.
Hero pose, Virasana, is a beginner seated pose. Kneel with feet together, sit back on heels, use blanket for support if needed. Opens hips, ankles, and thighs, promotes relaxation. Keep torso upright, avoid collapsing forward.
This is the step screenshot which you will need to submit to validate your result. And we are done with the code lab. Congratulations, you've successfully completed it. Great job on following along. See you in the next one. If you have any queries, please reach out to our leads on Discord. The QR code is on your screen. And this was Code Vipassana Season 9 Session 2, building a contextual yoga poses recommender app with Firestore, Vector Search, Langchain, and Gemini. Thank you.